So what does it really take to power the next huge wave of enterprise AI? Well, IBM is betting big that the answer is its new Power11 processor. And let me tell you, this isn't just some minor speed bump. No, this is a fundamental rethink of chip architecture, and it's designed from the ground up for the absolutely massive demands of AI and big data. So let's dive in and break down what makes this thing tick.
At the end of the day, the answer is pretty simple. Data and computational power, and a lot of it. You see, modern AI models are just incredibly hungry for processing power, and that creates these enormous bottlenecks for the hardware they're running on. And that's the exact problem IBM's Power11 is engineered to solve.
Okay, but before we jump into the future with Power11, we've got to look back a little bit. To really understand where it's going, you first have to see where it came from, because its biggest, most important innovations are all built on the foundation of its incredibly successful predecessor. You can really see the evolution here. It's a clear trajectory, right? Power 9 started things off by attaching AI accelerators externally. But Power 10? That was the real game changer. It was the first to bring those AI capabilities directly into the processor core, and that set a whole new standard for enterprise computing.
So, Power 10 was really all about two main things. First, you had that bulletproof, mission-critical reliability that the world's biggest companies absolutely depend on. And second, you had this groundbreaking move to, bake AI acceleration right into the silicon. That combination of rock-solid stability and forward-thinking innovation, it was the perfect launchpad for what came next.
All right, so that brings us to the main event, Power11. And the best way to understand its design is to look at it through these three core pillars of innovation. Each one is built to tackle a really critical bottleneck in modern computing.
The first pillar is all about just raw computational horsepower. Power11 gets this huge performance boost, and not just for making transistors smaller, but from a much smarter physical design. It uses something called a 2.5D architecture. The best way to think about it is like building a super dense, multi-story city instead of a sprawling suburb. It lets you pack all the components way closer together for much, much faster communication. And wow, the results of that new architecture? You see them immediately. In the most common server setups, you get a staggering 50% more cores, and they're all running faster than the previous generation. For any business, that translates directly into a massive leap in raw processing capacity.
And this isn't just on paper. Let's look at how this raw power translates to real-world performance. This table shows something called rPerf scores. That's an IBM benchmark for business application performance, and the gains are just huge, anywhere from 30 to 50%. For a company, this means they can consolidate way more work onto fewer servers, which saves a ton of money on things like software licenses and energy. But here's the thing. All those powerful cores are totally useless if they're just sitting around, starved for data.
And that, my friends, brings us right to pillar number 2, which is all about tackling one of the oldest and most stubborn problems in all of computing, the von Neumann bottleneck. It's this universal challenge where your super fast processor is constantly just waiting for data from a much slower memory system. And for AI workloads, this bottleneck is a massive problem.
So how do you solve this massive data traffic jam? Well, IBM uses a totally different approach. Instead of typical direct attached memory, they use something called OMI, or Open Memory Interface. Instead of a narrow one-lane road, OMI basically acts like a multi-lane superhighway, using this incredible high-speed signaling to deliver a massive amount of data right where it needs to go. And with Power11, this memory superhighway gets a truly massive upgrade. By moving to the new Odyssey DDR5 OMI memory, we're talking about a revolutionary threefold increase in memory bandwidth for each socket, jumping from 400 to a mind-boggling 1,200 gigabits per second. This is what ensures those powerful cores are never, ever left waiting for data. Okay, pillar 3. This is where the AI strategy gets really smart. It's evolved into this sophisticated two-tiered system. We went from external accelerators back in Power 9 to bringing AI inference right on chip with Power 10's Matrix Math Accelerators, but now Power 11 expands those on-chip capabilities and pairs them with a seriously powerful new attached accelerator called Spyre. And this whole strategy is about one simple idea: using the right tool for the right job. All the common, everyday AI tasks, what we call inference, are handled super efficiently by the accelerators that are built right into the processor core. And this frees up the heavy-duty Spyre accelerator to focus on what it does best: training and tuning those enormous AI models. The result is just way better system efficiency and a much lower total cost for running AI. Okay, so we've dug into the tech specs, the architecture, the memory, the AI strategy, but what does all of this cool innovation actually mean for a business? What are the real-world results?
First up, reliability. Power11 is designed for what's called 6 nines of uptime. That's 99.9999% availability, which translate to just seconds of unplanned downtime per year. Seconds. For systems that are running critical parts of our world, that level of resilience is completely non-negotiable.
Then you've got efficiency, which is huge these days. This platform delivers double the energy efficiency compared to similar x86 servers. In a world of rising energy costs and big sustainability goals, that performance per watt advantage means real money saved on power and cooling.
But numbers are one thing. A real-world story? That tells you everything. One of their customers found that a processing job that used to take 6 hours could now be done 18 times faster. Their VP of technology said it perfectly. The purpose of Power11 times is productivity. I mean, you can't get much clearer than that. It's a dramatic, game-changing result.
And on top of all that, the platform is just packed with features designed for today's challenges. On the security front, you've got forward-looking stuff like quantum-safe cryptography and the ability to detect and respond to ransomware in under a minute. And on the software side, it's built for modern cloud-native workflows, with seamless integration into tools like Red Hat OpenShift AI and IBM's Watson X.
Okay, to wrap things up, let's pull back for the big picture here. Because Power11, as cool as it is, isn't just the end of the story. It's actually a really critical milestone in a much larger strategic shift in how high-performance computers are being designed for the future.
You see, for decades, it was all about Moore's Law, just shrinking transistors to go faster. But that's slowing down. So the future of performance isn't just about making one chip faster anymore. It's about making the entire system smarter. This is a huge shift in philosophy, moving from a focus on the power inside a single chip to optimizing the data flow and speed across the entire server.
And this whole system-centric approach is the foundation for where IBM is going next. It relies on advanced packaging that uses something called chiplets. You can think of them like specialized Lego blocks that can be combined in different ways to build more powerful and more flexible processors. This method is what's going to allow for so much more performance growth for years to come.
So it really leaves us with this one big, important question to think about. As Power11 clearly demonstrates, maybe the future of performance isn't just about the power of the chip anymore, but about the intelligence of the entire system.